Hello and welcome to Train Signal. You are watching a lesson about Linux file systems. The first Linux operating system that I decided to use full-time was Ubuntu. My laptop at that time was struggling under the stress of Windows Vista and in terrible need of relief. The first time I installed Ubuntu, I downloaded the image, burned it onto a CD, and pretty much let the install take care of things for me from there. But as we've learned, it's often a good idea to segment your hard drive, putting directories like home and swap on their own partition. So I backed up my data and bravely started all over again. During our Linux installation lesson, we touched on the subject of partitions. In this lesson, we'll cover how to create partitions and what the associated file system types are. And as all file systems require a little loving care, we'll talk about how to do some maintenance and integrity tasks. Finally, we'll review how to mount and unmount a file system. Let's get started with how to create partitions and file systems. Normally, Linux will guide you through the partitioning process during installation, but if you add a new hard disk, or if you're like me and you just like to start over again, you'll need to be familiar with Linux's tools. First, you'll need to create the partition with fdisk, also known as fixed disk, then prepare it for use. Fdisk works on master boot record disks, and the command is fdisk space name of the device. Once you enter the utility, you can type P to display the current partition table. And at the fdisk prompt, you can use these commands. N creates a new partition. D deletes a partition. T will change the partition type code. L will list the most common type codes. A makes the disk bootable. And M is for help. To exit the program, you type Q, which will exit without saving, or W, which will write the changes to disk and then exit. You can also display your partition information without entering the utility by typing fdisk space -L. Let's take a look at that. Now again, another thing to reiterate about fdisk is that you won't be able to make changes to a mounted file system, but we can take a look at what we've already got configured. So let's go ahead and type in SU first to gain root privileges. Type in your password and hit enter. Now we're going to type in fdisk space -L, and that's the list option if you recall. Then we're going to enter the device name, which is dev SDA. It'll usually either be SDA or SDB. And go ahead and hit enter. And we can see the information here about how we currently have the disk configured and the hard disk layout. We have heads, sectors and tracks, cylinder information. Then we have our devices here. We've got SDA1, which is the boot device. We have where it starts and ends, an ID, 83, and we know that it's a Linux system. Then we've got SDA2. Again, we have the start and end information. And then we have here that it's a Linux virtual machine. When you prepare a partition for use, it's referred to as making or formatting the file system. And there are several file systems to choose from. The first is ext2fs, also known as ext2, and the extended file system was popular during the 90s, but nowadays the second extended file system is used mostly for small boot partitions or small removable disks. ext3fs, or ext3, is simply ext2 with journaling added. This allows for quicker recovery from system crashes. ext4fs, or ext4, is used mostly with newer Linux releases, and particularly systems with very large disks or files also use this file system. RiserFS, also known as Riser, is a journaling file system, and it's good for systems with large amounts of small files. JFS is developed by IBM for its AIX operating system and later for OS/2. It's mostly useful if you're already familiar with either of those operating systems. XFS was created by Silicon Graphics for their IRIX operating system, but the code was later donated to Linux, and some features still aren't well supported under Linux. BTRFS, also known as ButterFS, is very fast and it's able to handle large disks and files. It was inspired by Sun's zettabyte file system. Right now, though, this is still considered experimental. VFAT is used to add support for Windows-type long file names. FAT, or File Allocation Table, is the only file system supported by Windows 9 and DOS. It's best suited for exchanging data on removable disks. NTFS, or New Technology File System, is used by Windows NT and up to Windows 7, but it's fully supported by Linux. As of kernel 2.6.x, Linux can read and overwrite files on this file system, but it can't write new files to this partition. HFS and HFS Plus are Apple's hierarchical file system. It has full read-write Linux support, but it's not quite as reliable as FAT. ISO 9660 is a standard CD-ROM file system, and it has 3 levels, with levels 2 and 3 adding support for longer file names. Rockridge extensions enable support for Unix-type long file names, permissions, symbolic links, and more. Joliet is similar to Rockridge, but it was created by Microsoft for use with Windows. Linux supports Joliet as part of the ISO 9660 driver. UDF, or Universal Disk Format, is the next generation file system for optical disks like DVD-ROMs. Read-write support is still immature, though. As a general rule of thumb, use a Linux file system. Administrators will most commonly find themselves working with ext3, ext4, or RiserFS. Let's take a look at how to create a file system next. Once you've decided on the type of file system you want to use, it's time to create it. You can do so with the and the file system check order. And that concludes our lesson on Linux file systems. Let's review what we've learned on the next slide. Learning to create, modify, and maintain file systems and partitions are not only requirements for the Linux Plus certification exam, but also key components of a system administrator's duties. And in fact, regular users will even benefit from being able to troubleshoot and maintain their own systems. Doing so will earn you much praise from your IT departments. In this lesson, we covered creating partitions and file systems. We learned about the various types of file systems and under what circumstance each of them might be used. We talked about the essential task of tuning and maintaining the file system. And finally, we covered mounting and unmounting your file systems. Thank you for watching, and I'll see you in the next lesson.